Hi, Year 13. Today we're integrating particular types of function. We are starting to reverse the chain rule, but we're only doing a particular instance of the chain rule, and that's where the inner function is of the form ax plus b. So that's going to be your title there. So we're going to start with an example, go straight in. So I want to integrate cos of 3x plus 1, and we know that the outer function cos integrates nicely to sine of x. So what we're going to do is we're going to see what happens when we differentiate sine of 3x plus 1, because we reckon that's going to be pretty similar to what we've got in here. So sine of 3x plus 1 differentiates to, using the chain rule, 3 lots of cos 3x plus 1, because if you remember, the 3 in front of x is the inner derivative, and that comes out to the front. But this here is 3 times as big as what I want to get, which is 1 cos of 3x plus 1. So in order to account for that mistake, we're going to divide this by 3. So the antiderivative is actually 1/3 sine 3x plus 1, okay, plus c. All right, so the idea behind it is if you're integrating something of this form, then you integrate the outer function, so f dash is going up to f, but then to account for the a coming out when you differentiate, you need to divide by a in order for it to cancel out. Okay, so you can write this down as a formula if you need to, but that's the basic idea. So integrate and divide by a. So I'm going to do the questions on here, and then there's a slide of them that I'd like to do for today's lesson. Right, bear in mind your list of common antiderivatives as well. So the main function you need to know what the antiderivative is as well. Okay, e to the 3x. So that's exponential. We know that integrates back to itself, but there's a 3x, so we're going to divide by 3. So it's 1/3 e to the 3x plus c. And if you check, you can differentiate back again, and if you differentiate your answer, the 3 comes out, it clears the 1/3 back to a 1, and so it goes back to e to the 3x. Okay, 1/5x plus 2 is the next one. This is of the form 1/x, and the change in the inner function is 5x plus 2. 1/x integrates to ln, so 1/5x plus 2 will integrate to ln of 5x plus 2. But because of the 5, we're going to divide it by 5 as well. So it's 1/5 ln 5x plus 2 plus c. Okay, thirdly, a few more left. So we've got 2 sec squared, 3x minus 2 dx. The 2 at the front is just a constant multiple, so we're going to keep that as it is. It's not going to do anything. Sec squared integrates to tan of x. So sec squared of 3x minus 2 will go to tan of 3x minus 2. But because of the 3, we're going to divide everything by 3 as well. So it's 2/3 tan 3x minus 2 plus c. Again, if you're not sure, differentiate it back and it should make that again. Okay, 3x plus 4 cubed. So this is a polynomial function that we're trying to integrate, with the change in the input being 3x plus 4. So the outer function is the cubing. That's going to go to a power of 4, and then you're going to divide by 4. But you're also going to divide by the 3 to make it into a 12th at the front. So it's a 12th, 3x plus 4 to the 4 plus c. Okay, so these ones you've got to be careful of because there's 2 things to divide by. There's the new power that's on the bracket, and the inner derivative, which is going to be the value of a in front of x. Okay, it might be worth us writing down a general version of this. So if you're integrating, let's use some colours. So it's ax plus b to the n. Okay, so a linear bracket to the power of n integrated is going to have the same bracket, but it's now to the n plus 1. So raise the power up by 1, divide by the new power, and divide by a. So you're going to have this at the front. You're going to have 1/a lots of n plus 1. That's dividing by a. This is dividing by n plus 1. And then plus c as well. Okay, so that's going to be a special case if you want to refer to that one. So remember to divide by these things. Right, a couple more to go. Sine of 1 minus 5x. Sine integrates to minus cos. The bracket's going to stay the same, but you're going to divide by minus 5, and dividing by minus 5 will cancel the other minus sign. So it goes to cos 1 minus 5x times a fifth plus c. And then finally, this one here is a special case of, well, it's one of these, isn't it? It's a bracket to a power with a third next to it as well. So the power is going to go up by 1. Think of this as bracket to the minus 2. That's going to go to bracket to the minus 1. You've already got a third, and you're also going to divide by 4. Minus the 12th, 4x minus 2 to the minus 1 plus c. And the minus there is because of dividing by minus 1. Right, okay, that should be enough examples for you to get the idea. Again, I'm free for you to give me a shout if you need any help. But the ones I want you to do today, please, are on the slide over here. Okay, there's a fair few there, and this is from exercise 11b. You can do them without uncovering these green boxes, and then to check your answer, you can obviously uncover them as well. Right, very best of luck. If you need anything else, give me a shout, and I can give you some advice there. Otherwise, enjoy your day, and I'll see you soon, Year 13. Thanks very much.